Well, faults are usually the result of plastic deformation. By that I mean that when they are deformed, they flex, they bend and twist like a putty. Much harder rock material, when put under compressional or extensional pressure, will instead fracture. It will break apart very quickly and suddenly. And when this happens, the resulting features will be called a fault. Now, faults come in several different forms, but there are three that are worth talking about. First of all, we have normal faults, which happens when the hanging wall, the block that is angled upwards relative to the other side, moves downwards. And this is a result oftentimes of extension in an area. When the crust extends, it puts tensional pressure on the rock, and when it does, eventually the rock shatters, and when the fault forms, the overhanging block slides down under the force of gravity. The second type, which is what we have right here, is what we call a reverse fault, which, as you might imagine, entails the exact opposite, that the hanging wall is instead moved upwards. Reverse faults are much more common to see in compressional situations, where the crust is being squashed together. Again, much like you would see in a typical fold. Now, the thing about reverse faults that's sort of interesting is that there are actually two classes. Normal reverse faults have a dip angle, or they slide down an angle of about 45 degrees or more. But when you have an angle of about 30 degrees or less, you get what we have behind us, which is a thrust fault. And as you can see from over this way, you can take the fault trace from down in this corner over here, all the way up in that direction. And you can easily see the fault because in the middle section here we have is what we call a drag fold. What happens is that sometimes when the rock material breaks, not all of it breaks smoothly, and as a result, when the movement occurs, it actually contorts and drags part of one side down with it, or in this case, up with it, as the fault moves. The third type of fault is called a strike-slip fault. These are considerably different from normal and reverse faults because there is no vertical movement. There is no block that's sliding downwards or upwards. Instead, we have two pieces of crusted material that are effectively grinding against one another horizontally. As a result of this, these faults are generally not associated purely with extension or compression. They tend to instead be due to lateral or shear movement, which makes them very common in areas where you have large pieces of crusted material grinding against each other. A good example would be the San Andreas fault system, which comprised of hundreds of small strike-slip faults that just happen to be oriented in a relatively similar direction.